America is building things again. Not just buildings, not just roads. We're talking about projects so massive they'll reshape entire industries, redefine what's possible, and cost more money than some countries produce in a year. A semiconductor factory in Arizona that could fit 11 football fields. A hydrogen hub that'll power half of Texas. Infrastructure that makes the Hoover Dam look like a weekend DIY project. These aren't plans on paper. They're being built right now. And most people have no idea they exist. Let's fix that. Project number 10. The Gateway Program, New York and New Jersey. You know what's older than your grandparents? The train tunnels connecting New York and New Jersey. The North River tunnels opened in 1910. That's 115 years of trains running through tubes under the Hudson River. They were built for steam locomotives, and now we're running modern electric trains through them at volumes the designers never imagined. Here's the problem. Hurricane Sandy in 2012 flooded these tunnels with salt water. Salt water and century-old infrastructure don't mix. The concrete is crumbling. The electrical systems are failing. The tunnels are literally falling apart. And we're sending 200,000 people through them every single day. It's not a question of if they'll fail completely. It's when. The Gateway Program is the fix. And it's probably the most important infrastructure project most people have never heard of. 2 new tunnels under the Hudson River. A new bridge over the Hackensack River. Complete reconstruction of the old tunnels. The price tag? $16 billion. That's billion with a B. But here's why this matters beyond just trains. The Northeast Corridor generates 20% of America's GDP. 1/5 of the entire economy runs through this region. If those old tunnels fail catastrophically, if trains can't move between New York and New Jersey, the economic damage would be in the hundreds of billions. This project isn't about making things better. It's about preventing economic catastrophe. Construction started in 2023. The new tunnels are being bored through bedrock 90 feet below the river. Each tunnel will be 2 miles long and wide enough for 2 tracks. The boring machines doing this work are massive, 350 feet long, basically underground factories that dig, remove debris, and install tunnel lining all at once. They move about 40 feet per day, which sounds slow until you realize they're cutting through solid rock under a major river while the city above continues operating normally. The project should finish around 2035, which sounds like forever from now, but that's actually pretty fast for something this complicated. When it's done, the Northeast Corridor will have the capacity to handle 50% more trains. That means more freight, more passengers, less congestion, and an economic boost that'll ripple through the entire region. Project number 9. The Texas Hydrogen Hub. Oil, obviously. Natural gas, beef, trucks that are unnecessarily large. But here's something new to the list. Hydrogen. Not the kind that floats balloons. The kind that could replace fossil fuels in heavy industry. The Texas Hydrogen Hub, officially called High Velocity, just received $1.2 billion in federal funding. The total project cost is closer to $7 billion when you add private investment. This isn't one facility. It's a network of hydrogen production sites, storage facilities, and distribution infrastructure across the entire state. Some industries can't easily switch to electricity. Steel production, chemical manufacturing, long-haul trucking. They need something with hydrogen's energy density. Most industrial hydrogen is made from natural gas, which defeats the purpose if you're trying to reduce emissions. This project is different. It's focused on clean hydrogen, produced using renewable electricity or with carbon capture. The hub will produce up to 1 million metric tons of hydrogen per year by 2030. To put that in perspective, that's enough to replace about 40 million barrels of oil annually. The project spans the Gulf Coast from Corpus Christi to Houston, connecting refineries, chemical plants, and manufacturing facilities. It's using existing pipeline infrastructure where possible and building new pipelines where necessary. Port facilities are being upgraded to handle hydrogen exports, because Europe and Asia are desperate for clean energy sources. This could become a major export industry. Texas, already the energy capital of America, is positioning itself as the clean hydrogen capital of the world. The economic impact estimates are huge. 45,000 direct jobs during construction and operation, billions in economic activity, and a template for how other states could build similar infrastructure. But there's a catch. Hydrogen is tricky. It's the smallest molecule in the universe, which means it leaks through materials that hold other gases just fine. It can make certain metals brittle. Storage and transport require specialized equipment. The technology exists, but scaling it up is the challenge. This project is essentially a massive real-world test of whether hydrogen can work at industrial scale. If it succeeds, expect similar hubs to pop up across the country. Project number 8. TSMC Arizona. The Chip Factories. Taiwan Semiconductor Manufacturing Company. TSMC makes about 90% of the world's most advanced computer chips. Your phone, your car, your laptop, they all have TSMC chips in them. The problem? TSMC's factories are all in Taiwan, and the geopolitical situation there is, let's say, uncertain. So TSMC is building 2 massive semiconductor fabrication plants in Phoenix, Arizona. Total investment is $40 billion. That's not a typo. $40 billion for 2 factories. Why so expensive? Because these aren't regular factories. Semiconductor fabrication plants, or fabs, are the most complex manufacturing facilities humans have ever built. The first fab is expected to start production in 2025. The second follows in 2026. Each fab will employ about 6,000 people directly, with another 10,000 jobs in supporting industries. But here's the wild part. These facilities are so clean that the air inside is 1,000 times cleaner than a hospital operating room. They have to be. Modern chips have features measured in nanometers. A single dust particle is enormous at that scale and can ruin an entire batch of chips. The buildings themselves are engineering marvels. That's how precise this manufacturing is. A car driving by outside can't be allowed to shake the equipment. The environmental control systems maintain temperature within a fraction of a degree and humidity within a tiny range. The water purification systems produce water cleaner than anything found in nature. These fabs will produce chips using TSMC's 4-nanometer and 3-nanometer processes. To give you context, modern chips have transistors so small that if you scaled a transistor up to the size of a marble, a human hair would be about 10 miles wide. We're operating at the absolute edge of what physics allows. Why Arizona? Water might seem like an issue, and it is a concern. But Arizona offered massive incentives. It has a stable power grid, and it's far from potential geopolitical hotspots. Plus, the semiconductor industry already has a presence there. Intel has fabs in Arizona. There's existing expertise and infrastructure. The economic implications are massive. Right now, America produces about 12% of the world's semiconductors, down from 37% in 1990. These fabs won't reverse that trend alone, but they're a start. More importantly, they reduce America's dependence on chips manufactured in geopolitically sensitive areas. During the pandemic, when chip shortages shut down car factories and made PlayStations impossible to find, the strategic importance of semiconductor manufacturing became painfully obvious. Project number 7. The Gordie Howe International Bridge. Connecting Detroit, Michigan and Windsor, Ontario, this bridge has been in planning for so long that people joked it would never happen. Turns out it is happening, and it's spectacular. Making it the longest cable-stayed bridge span in North America. Construction started in 2018 and should finish in 2025. The Canadian government is paying for the entire thing, all $4.8 billion, which is either incredibly generous or a sign of how badly they need better border infrastructure. Probably both. Here's why this bridge matters. Which connects the same 2 cities. Handles about 25% of all trade between the US and Canada. That's $140 billion worth of goods, crossing every year on a single bridge built in 1929. If that bridge failed, even temporarily, the economic damage would be catastrophic. The automotive industry alone would be devastated. Just-in-time manufacturing means parts cross that bridge multiple times during assembly. A disruption would shut down factories on both sides of the border within hours. The new bridge will have 6 lanes instead of the Ambassador Bridge's 4, plus dedicated lanes for trucks. It'll have better customs facilities on both ends, reducing wait times. The bridge deck is 138 feet above the water, high enough for tall ships to pass underneath. The towers rise 722 feet, visible from miles away. But the really interesting part is the border crossing infrastructure. Getting goods across international borders is complicated. Customs, inspections, security, it all takes time. The new bridge has inspection plazas, designed to process trucks faster using technology that scans entire vehicles in seconds. Radiation detectors, X-ray systems, automated license plate readers, all working together to keep trade flowing while maintaining security. The construction itself is impressive. The bridge towers required over 25,000 cubic yards of concrete each. The cables holding up the deck are made of thousands of individual steel wires bundled together. The entire structure is designed to withstand earthquakes, high winds, and the weight of thousands of trucks crossing simultaneously. Economic estimates suggest the bridge will create $5 billion in economic benefits over 30 years. That's jobs, increased trade, reduced shipping costs, and improved efficiency. For every hour saved at the border, companies save money. Multiply that across thousands of trucks per day and it adds up fast. Project number 6. The Los Angeles River Revitalization. The Los Angeles River is one of the saddest rivers in America. It's basically a concrete drainage ditch that occasionally appears in movies during car chases. For 51 miles it runs through Los Angeles County, completely encased in concrete, looking like a freeway for water instead of cars. But that's changing. The LA River Revitalization is a multi-decade, multi-billion-dollar effort to transform portions of this concrete channel back into something resembling an actual river. We're talking about removing concrete, adding vegetation, creating parks, building bike paths, and reintroducing natural water flow. The total cost is estimated at $50 billion over 30 years. That's an insane amount of money for a river project. But here's the thing. This isn't just about making the river pretty. It's about water management, flood control, recreation, real estate development, and addressing climate change impacts. Los Angeles has a water problem. The city doesn't have enough of it, and what it does have comes mostly from hundreds of miles away. The LA River, despite running right through the city, doesn't contribute much to the water supply because it's designed to rush storm water out to the ocean as fast as possible. The revitalization project includes building systems to capture and treat stormwater, turning it into usable water. That could provide up to 50,000 acre-feet of water annually, enough for about 100,000 households. When it rains in LA, it really rains. The concrete channel was built specifically to prevent flooding, and it works. But it also creates problems downstream. All that water rushing through at high speed causes erosion and carries pollution straight into the ocean. The new design includes wetlands and vegetation that slow water down naturally, filter pollutants and recharge groundwater. The recreation aspect is huge too. Right now, the river is mostly unusable. Once the project is done, you'll have 51 miles of connected parks, trails, and green space running through one of the most densely populated areas in the country. Real estate values along the river are expected to skyrocket. Economic development in adjacent neighborhoods could generate billions in tax revenue. Parts of the project are already complete. The Glendale Narrows section has portions where you can actually see the river's natural bottom, where birds nest, and where kayakers paddle. It gives you a glimpse of what the entire river could become. Other sections are still in planning or early construction. This is a generational project. People working on it now won't see the final result. But when it's done, Louisiana will have transformed an ugly concrete channel into an actual civic asset. Project number 5. Starbase, Texas. Elon Musk is building a spaceport in South Texas. And it's not just a launch pad. Starbase is an entire city dedicated to building and launching starships, the largest rockets ever constructed. This facility makes NASA's Kennedy Space Center look quaint. The infrastructure includes launch pads, manufacturing facilities, fuel production plants, and housing for workers. SpaceX has invested over $3 billion so far, and that number keeps climbing. The goal is to launch starships multiple times per day eventually. Not per month, per day. Why does this matter for America's economy? Space is becoming an industry, and whoever dominates launch capabilities dominates the industry. SpaceX launches more tonnage into orbit than every other country combined. Starbase is where they're scaling up to make space access routine and cheap. The economic impact on South Texas has been dramatic. The nearest city has seen population growth, rising real estate values, and new businesses catering to SpaceX employees and space tourists. Restaurants, hotels, and services are all expanding. It's not just about rockets. It's about creating an entire ecosystem around space access. The site is near wildlife preserves and the Gulf of Mexico. Launches are loud, and rocket debris sometimes falls in protected areas. SpaceX and regulators are still working through these issues. But the economic and strategic importance of having advanced launch capabilities on U.S. soil is hard to overstate. Project number 4. The I-70 Mountain Corridor Expansion, Colorado. Interstate 70 through the Colorado Rockies is one of the most beautiful and frustrating highways in America. It's also one of the most dangerous. This 144-mile stretch of highway between Denver and Glenwood Springs handles 30,000 vehicles per day during peak season. It was designed for maybe a third of that. The expansion project costs $5 billion and includes adding lanes, improving interchanges, and building wildlife crossings. The most ambitious part is widening the highway through tunnels and narrow mountain passes, where there's literally no room to expand. In some sections, they're excavating into solid rock to create space. Why spend this much on a highway? Because this corridor is an economic lifeline for Colorado's mountain communities. Ski resorts, tourism, and all the businesses that depend on them rely on people being able to get through. During winter weekends, traffic can back up for miles. A drive that should take 2 hours can take 6. That's not just annoying. It costs money. Tourists who can't reliably get to destinations go elsewhere. The project includes innovative safety features, like variable speed limits based on weather conditions and dedicated lanes for different vehicle types. They're also building wildlife crossings, bridges that let animals safely cross the highway. These reduce collisions with wildlife, which are both dangerous for people and devastating for animal populations. Construction in the mountains is incredibly difficult. Work can only happen during certain months because of weather. Materials have to be trucked in on the same highway they're trying to improve. Crews work at high altitude where the air is thin and weather can change instantly. The project timeline extends over a decade because of these challenges. Project number 3. The Midwest Hydrogen and Clean Energy Corridor. This project connects North Dakota, South Dakota, Nebraska, and Kansas in a regional clean energy network. It's building wind farms, solar installations, hydrogen production facilities, and the transmission lines to connect them all. Total investment exceeds $10 billion from public and private sources. The Midwest has some of the best wind resources in the world. The wind across the Great Plains is constant and strong. This project harnesses that wind, converts it to electricity and hydrogen, and distributes both. The hydrogen component is particularly interesting. Excess wind energy, instead of being wasted, gets used to produce hydrogen through electrolysis. That hydrogen can be stored and used later, effectively solving the renewable energy storage problem. The transmission lines are crucial. Right now, electricity generated in the Dakotas can't easily reach cities where it's needed. This project builds high-voltage direct current transmission lines, capable of moving gigawatts of power across state lines with minimal loss. These lines cost about $3 million per mile to build, but they enable the entire system to work. Economic impact estimates suggest 20,000 permanent jobs in operation and maintenance, plus tens of thousands of construction jobs. Rural areas that have struggled economically for decades are seeing investment and opportunity. Farmers are leasing land for wind turbines, generating steady income. Small towns are getting tax revenue from energy facilities. It's revitalizing regions that had been left behind. Project number 2. Port of Savannah Expansion. The Port of Savannah is America's fastest-growing container port, and it's undergoing a massive expansion to handle even more cargo. The project includes deepening the harbor to 50 feet, expanding container yards, adding rail infrastructure, and improving road connections. Why Savannah? Location. It's the closest major port to the industrial Midwest. Cargo arriving in Savannah can reach more of the U.S. population faster than cargo arriving in LA or New York. During the pandemic supply chain crisis, Savannah handled overflow from congested West Coast ports. Ships literally rerouted from California to Georgia because Savannah could unload them faster. The harbor deepening allows larger ships to dock, carrying up to 24,000 containers. These ships require deep water, Before the expansion, the largest ships couldn't enter Savannah fully loaded. Now they can, making the port more competitive. Cargo has to get from the port to its final destination. Savannah is building what's essentially an on-site rail yard, where containers get transferred directly from ships to trains without trucks involved. This is faster, cheaper, and reduces road congestion. The port will handle 1 million container movements by rail annually, taking 200,000 truck trips off highways. The port supports 500,000 jobs across multiple states. Every container that moves through creates economic activity. This expansion positions Savannah as the dominant port on the East Coast for decades. Project number 1. The National Quantum Initiative. This isn't a single construction project. It's a coordinated federal program, investing $1.2 billion into quantum computing research, with universities, national labs, and private companies contributing another $3 billion. Research hubs are being built at the University of Chicago, MIT, and other institutions. Why does this matter more than physical infrastructure? Because quantum computing will revolutionize everything: drug discovery, materials science, cryptography, artificial intelligence, financial modeling, climate prediction. Any field that requires massive computational power will be transformed. Right now, America leads in quantum research, but China is investing heavily. Whoever achieves quantum advantage first, whoever builds scalable quantum computers first, gains an enormous strategic and economic advantage. This isn't just about having faster computers. It's about solving problems that are impossible for regular computers. Designing new materials by simulating quantum interactions. Breaking encryption that protects global financial systems. Optimizing logistics for entire industries simultaneously. Software, workforce training, and infrastructure. They're building specialized facilities where quantum computers can operate, requiring extreme cooling and isolation from interference. They're training the next generation of quantum engineers. They're establishing standards and protocols so quantum systems can work together. The economic potential is staggering. Estimates suggest quantum computing could generate $850 billion in annual economic value globally by 2040. America capturing even a fraction of that market means trillions in economic impact over time. These 10 projects represent over $100 billion in investment. Energy, technology, manufacturing, and basic research. They're creating hundreds of thousands of jobs. They're positioning America for economic competition in the 21st century. And most importantly, they're all actually happening right now. Not concepts, but concrete and steel and microchips being built today to power tomorrow's economy. Thanks for watching. Hit subscribe if you want more deep dives into the projects reshaping our world.